In this video I'm going to cover generative art. There are many different approaches to procedural generation of content in Twine. This example covers using patterns, random generation, noise generation, and combining these with timing to generate and show content. All of these examples also use the SugarCube 2.21 story format. So let's start and look through these. Let's start with basic patterns. So we see here a basic pattern using random generation. We'll look at the code in a few moments, but this is choosing one of three different patterns, either stars, @ or equal sign, and then generating them each time, creating a generative art pattern here, using three different choices and either 3, 5, or 8, depending on which one is selected. It's a pretty simple demonstration of creating generative art, not using a lot of rules, and we'll go over this again when I get back to the code. This example uses a random number 1 to 3, picks one of these patterns, and then simply prints it. And then we run a bunch of loops of this to generate new patterns. So a simple example using basic patterns. Let's go back. We can also do that with random characters. This is just random characters here. It's generative art in that it was generated for an art purpose in this case, but it doesn't do a whole lot for us. But we may be able to use it for other things, converting some of this text into words, or providing back with the basic patterns, ways of generating new patterns based on these same techniques. And I'll review the code once we go over all of these examples. Next one is generate repeating character patterns. So we see the same character patterns we saw previously, but now we're seeing them being updated with timing here. And it's generative art updating every few seconds, and we're seeing just randomly generated punctuation, letters and numbers, uppercase and lowercase, and just randomly generated here in a repeating pattern. Going back again, let's look at erasure patterns. A common form of poetry is erasure poetry, or sometimes blacked out poetry, depending on what you've seen and how it's been called. But the core of this is to take an existing text and to erase parts of it, so that it creates a new text that can then be usually transformed into poetry, or in this algorithmic case, transformed algorithmically by taking a text, transforming it, and then replacing certain words or certain phrases. In this example, I've taken part of the dialogue from War of the Worlds and erase parts of it randomly. And in fact, if we go back and run this again, we'll see a whole new erasure pattern. All this is simple substitution. We're taking a text, breaking it down into its components, erasing parts of it, and then putting it back together again. The same as erasure poetry in a physical setting, but in this case digitally done it for a generative art sense. And I'll cover how to do this when we look at the code. The other two examples we're going to look at are noise generation. If you're not familiar with noise generation in programming sense and mathematical sense are ways to create random patterns that are based on mathematics. Usually using pseudo-randomness, which computers can generate, we can get chaotic systems. Sometimes we want sort of a uniform randomness, which may seem paradoxical in its approach. Why would you want uniform randomness? But we want a way to generate randomness we can predict and generate randomness that falls within a certain scope. In the case of the algorithms I'm using here, and I'll go over them, it is a take on the Perlin noise algorithm using the simplex approach, which is all sort of gobbledygook if you don't really care what I'm doing, but just to know that these are noise generation patterns that follow sort of uniform randomness in a way, where we generate a number between -1 and 1. And we know within a certain span what those numbers look like and a general uniformity over a certain time period, how those patterns will fall. But they're still random, but they're random within a certain scope and driven mathematically. All that's to say, let's look at generate noise patterns. Well, we see either backslash or forward slash here. And these are based on either the number that generated was less than 0 or greater than 0. And we see we can generate sort of forward slash or backslash just to create a simple pattern here. Generative art using noise generation and just checking binary. Is this greater than 1? Is this less than 1? Forward slash backslash, and we just generate them. But we can also do the same thing we did with repeating character patterns by using repeating noise patterns, by just recalling those same noise functions and generating new numbers and redrawing the same lines. And we see here the lines moving back and forth because it's redrawing this grid every time here. So we're just repeating, calling our noise function to generate a new number between -1 and 1. And if it's less than 0, it's a forward slash, or it's 1 slash. If it's greater than 0, it's another slash. And it would just keep calling this every 1 second, and the numbers flip, and it creates sort of a weird pattern based on this noise generation, this uniformity random generation. But then now that I've gone over all of these different possible examples of doing this, let's go and look at the code for all of this. So looking at the story map view, we see my start passage pointing out to a number of different passages. Let's start with generate basic patterns, the first example I talked about. And we see here it's exactly how I explained it. We did 500 loops using a for macro from 0 to 500. So from 0 to 499, less than 500. So 500 loops. We get a random number, 1, 2, or 3. If it's 1, we printed 3 @ symbols. If it was 2, we printed 5 equal signs. And else, if it wasn't 1 or 2, we printed 8 stars. And that was our very basic pattern. Choose one of 3 different things and just print them. And we see a very simple but somewhat engaging art presentation using this generative approach of choosing one of a couple of different patterns, using a random number, and just printing them. So again, using the for macro, running a bunch of different loops, getting a random number, based on that random number, jittering one of 3 different patterns. We could also extend this to a large number of other patterns and just follow the same approach of using basic patterns, stringing them all together, using randomness or other rules we may want to write into this. The other example I looked at was generate random characters. And we saw here just random character presentation. So let's look at that. Generate random characters. Well, it's the same general structure. We're still using the for macro. We're doing 500 loops. We're getting a random number, in this case from 32 to 126. Then we're using part of JavaScript here, using from character code. The character code are numerical positions of characters within the ASCII character way of presenting characters, basically. These are a way of encoding characters as numbers. And they have a very long history. They've been around for decades. But basically it means that there are character codes representing all of the normal characters you may use. So we saw here uppercase, lowercase, Roman characters, punctuation, and everything like that. And those are defined from 32 to 126 within the character codes. So we just pick a random number, and then we convert from character code from their number equivalent back into their string equivalent. And it's just some JavaScript code here that we're doing this. So string from character code, we picked a random character code, 32 to 126, convert the character code back to string, and we print it. Pretty simple, actually. So we just call this 500 times and just print a bunch of random characters. Not terribly exciting, but one way to approach this. The other example we saw was repeating patterns of this. Of just showing the new characters every 1 second, just updating new random generated characters. So this uses the same central idea again. 500 loops, random character, set an array. In this case, we're now using an arrays to save all that, so we're generating it all, and then we're showing it. But in this case, we're using the replace macro to replace an element with a class art. That's what the dot means. So up here is an element with the class art. So we're replacing it with the contents of the array character array. And we're doing this every 3 seconds. So just keep looping, and we keep getting new character codes, converting the character codes into strings, replacing them in a character array, and then we're printing the contents of the array, replacing that in the element with the class art. And we just keep doing that every 3 seconds. So this is one way to approach this then. We can generate random character patterns. We could even mix this with basic patterns to create sort of engaging different patterns and randomness put together here, depending on how chaotic we want these systems to be. The other example we looked at was erasure patterns. So let's look at that. Generating erasure patterns in this example code follows similar other techniques I've highlighted in this series of procedural generation in Twine. In this case, we're using storyGet, a function in SugarCube, to get a passage with the title War of the Worlds. Then I'm combining it here, getting the text of that passage. So we go get a passage as a passage object. All passage objects have a property text that is the text of that object. So we're getting the text of a passage called War of the Worlds. Then we're using a string function here called split. So we're splitting this string content array into split array. So split on all of the spaces. So we're taking the entire text, splitting it from its spaces, that is, divide up the string, split it into an array of its content. Then we're using a similar setup that we've used repeatedly throughout all of these examples, and in this case we're running 900 times, just for a really clean randomness here. So we see lots of words and lots of things are getting erased. Then we're replacing it with 2 dashes. We're getting a random entry from 1 into its length, so whatever it is, up to its length, we get a random entry. We swap it with 2 hyphens. Then we do the whole thing over again. And in this case, we run the array again from 0 to its final length. And then we print it 1 entry at a time. Just like we saw here. We ran through this by taking a passage, splitting it into text, taking the text, randomly substituting hyphens, and then we reprint it out again. But as I mentioned, this uses War of the Worlds. So let's pause and go look at that. Well, this is just text I copied here. Put into this passage. It's split on spaces. So we're looking at words most of the time. And then again, if we don't like those from one space to the next, for example, and they here for present, we can swap it out with hyphens and create erasure poetry using the same approach we've been doing throughout this. Again, loops looking at randomness. The last example here, or the last of 2 different examples here, are generating noise patterns. Well, similar approach. But in this case, we're building a grid. The simplex noise generation algorithms work best with grids. Because as you see here, we need an I and a K, or depending on whatever you want to call them, an X and a Y, to generate a complete grid for uniform randomness across that, taking into account all of the entries in the grid. So we're doing a 20 by 20 grid, which we see here, and same thing we saw before. Splitting if it's less than 0, do 1 slash, else do the other slash. And we're escaping this using SugarCube's syntax to escape this so it doesn't become anything else, and we just can look at these symbols, and we're just running this. So creating a 20 by 20 grid, and sending us to window noise simplex 2. Simplex 2 is 2D. We could also do 3D. And if we really wanted to come in here and change the algorithm, you can do up to any multi-dimensional pattern you want. But in this case, it's just 2D because we just need a 20 by 20 grid. Well, I'm going to pause here and go look at the JavaScript, which I'm not going to go over because it's very long and involved, and I don't even understand all of it. But this is a Perlin and simplex noise algorithms for 2D. You can see the code at this GitHub site. The code is placed on public domain, but I've gone ahead and attributed using the same attributedness that the author used. And I've tweaked it just a little bit here. So we're using the window and window noise, and at the very end, we're returning window. The code uses something slightly different, but I'm going to encourage everyone to use window or a similar global object in JavaScript. And all this does is generate all of these different noise functions. You're welcome to look through it. I don't even completely understand it, but it does what it's supposed to do. So we have this black box code in this case that will generate simplex noise patterns for us from -1 to 1, and we can then use those, as we saw, to generate a noise pattern, either the backslash or forward slash, depending on what we get as a result of calling that function. So we can just include this code as sort of black box code. We don't really care about what it does as long as it does what we need it to be, what we need it to do, that is. And then we can generate 20 by 20 grid and generate those patterns for us. We can also, finally, as we saw, do repeating noise patterns. This is the same general approach we've been using throughout this. We run our loops. In this case, 20 by 20 grid, just like we just had in the previous passage. We either backslash or forward slash, depending on the outcome of this noise generation from -1 to 1. We check to see if it's less than 0, we do one thing. If it's not, we do something else. And just to be doubly sure, we can seed this function with randomness each time, just to make sure there are random entries in this every time we run it. We're using a similar approach that we did before, replacing an element with the class art right here, and we're repeating this every 1 second. And as we saw, we get this fun pattern where we just check, is this less than 0? We do one thing. If it's greater than 0, do the other thing. And we get a fun little generative art pattern. Well, all of these different approaches share what I've highlighted here. Basically 4 loops, where we pick the number of loops we want to do, 500 in one case, 900 in another, 20 by 20 grids. But we understand what we want to do before we proceed out to generate the art, which kind of makes this different from a lot of other projects, where we plan out patterns we want, or randomness we want, or what algorithms we want, and then we tweak them along the way. So we author the randomness in bits and parts, so we're still getting that randomness and those bits of chaotic complexity. But we're doing so in such a way that it's authored enough that it looks a little more like art and not just sort of chaos. As we saw with sort of the generate random characters, where that's interesting, but it's sort of too chaotic for us to make something out of it. Whereas the repeating noise patterns actually look sort of hypnotic with it switching back and forth and creating different layouts. In all of these cases, though, we're generating different art patterns based on these basic approaches. We're using patterns, we're using randomness, we're doing noise patterns, and we're repeating these, in most cases, using a timing of some sort. All of these are different ways to approach generative art in Twine. Again, basic patterns, randomness, and in almost all cases, using for loops and understanding what we want to generate as our output, and then tweaking it along the way to generate just what we want out of it. A link to this example we provided in the YouTube description of this video, as well as a proof copy of the same code. Thanks for watching.